So in fact, right, I actually forgot to talk about in v9.13, alright, the previous video, alright, is that I forgot to talk about cold deformations or coldworking. So we say that there's transformation hardening, we got special machining techniques like short pinnings, which we actually just now, but we didn't talk about the coldworking. So therefore, let's talk about the coldworking in this section right now. Let's take a look on this thing. Am I recording? I think I'm recording. Yeah. Anyway, so yeah. So this is the hot rolling process.
Steel is highly resistant to shaping when it's cold, and for that reason it is generally rolled whilst it's hot. To make sure the steel is at the correct temperature for rolling, it is fed into a furnace. Here it travels through several temperature control zones until it's at the correct temperature and ready for rolling. Whatever the product, the principles of hot rolling are the same. Steel is squeezed between rolls until the final thickness and shape are achieved. To do this, the rolls must exert forces of tens of millions of newtons, equivalent to a weight of thousands of tons. The rolls, therefore, run in massive bearings, mounted in housings of enormous strength and driven by powerful electric motors. These are known as mill stands. The layout of a rolling mill can vary from a simple single-stand mill to several stands positioned either side by side or in a line. The mill rolls themselves can either be plain for flat products such as strip, used for products such as cladding, or profiled for sections, beams and columns for use in construction. Mill stands have various roll arrangements depending on the product being rolled. The simplest arrangement is a two-high stand, used mainly for long products such as sections. For light sections and bars, three-high stands are sometimes used, with the steel passing one way through the bottom gap and back through the top gap. Four-high stands have two work rolls in contact with the steel, supported by larger backup rolls to prevent distortion caused by the rolling face. These give greater accuracy for rolling flat products, such as plate. Universal beam mills include stands with both horizontal and vertical rolls bearing on the steel simultaneously. The rolled steel is then cooled in a way appropriate to its end use and prepared for further processing or dispatch.
Yeah, so I think you can go to this video. Is a very important video. Alright, at least you get to know the understandings of the co-working process. Alright, but if you want to know more, alright, you can actually go to this. Actually, this is not co-working. Alright, and it's pretty interesting of how the different hammer forging. Alright, these are all the different things. You can skip the video next. Alright, these are all the things that I think put here in case in the future you need it. At least you can come here straight away. No need to find. Alright. So these are the ways to forge the thing. I don't know what it's doing, but yeah, it's open die forging. Wow, I think the level very high. It's trying to make the shape out through the forging, you see. Yeah, so they are like really seriously doing this. Yeah. Yeah. So this is more on the more professional side lah. Okay. Nonetheless, you can go to hot and cold working. Alright, this one. There is a theoretical stuff on it. I'll not explain. In the future you need it, you go and search it out. So I think this is it for the co-working process, in case that you may want to know. So also the co-working itself is also to hit it to martensite. Alright, so all along, right, it just you need to take note that for modifying surface structure, because you want a high strength, definitely you want it to have martensite. Okay, the structure. Alright, so therefore you will need to have fast cooling. Just now if you see the video, they cool it very fast. Right, and just on the video. But anyway, I think this is it lah. See you.